Hello my dear champions, welcome back to our channel Deeksha Karnataka. Today I'm here to help you out with the chapter Determinants in the series Masterstroke. Okay, what we are doing right now, what we are doing is very simple, solving each and every chapter in Masterstroke in your PU2 syllabus one by one in our Masterstroke series. Okay, again PU1 chapters will be coming but after your boards are over. Right now this series will help you score good marks in both CET and PU2. Okay, so a very simple chapter but has quite amount of weightage in both boards and KCET, so we have to be careful in this and we have to learn all the concepts, and this is the last time and right time to revise all of these ones because we still have some time before examination starts, and that's why I'm here with this particular unit. Okay, so before I begin, what you have to do, all of you have to join me in this journey. How can you join me? By simply subscribing to our channel, simply joining us, letting us know what is your query, your doubt, because you've seen that whatever you asked, we deliver it on the time on our platform. Okay, so simply let your queries, let your concerns to us, let us know that by the comment sections. Use the comment section to give your asks and we'll fulfill that. Okay, and of course, to get all the notes and everything that you need, all the updates regarding all the classes coming or your examination, to know that, join the WhatsApp community. The link for that will be given in the description of this particular video. Go check it out. Okay, so let's start right now. Yes sir, the determinant chapter. So first of all, what is determinant? We all know that very well. Determinant is a scalar value associated with what? A square matrix. So we have learned in the previous class what is a matrix, right? The rectangular array where we store the data in, whether it is variable or numbers form, rational number doesn't matter. Okay, but what is going to be a case of square matrix? When the number of rows and number of columns becomes what? Same. It means a matrix of the order 2 cross 2, a matrix of the order 3 cross 3 and so on, which is going to be called a square matrix, and there will be always a scalar value associated with each of these matrix, and that's called as determinant. In our syllabus we have to deal with only 2 cross 2 to 3 cross 3 matrix for determinant. We don't have to deal with 4 cross 4 or 5 cross 5 for the syllabus of PU2 and KCET. Okay, we have not seen a question like this in our PYQs where it says that you need to study the 4 cross 4 matrix also, not required. Okay, so this is your matrix ABCD and this is the representation of a determinant. You remove the brackets and write this lines, which is similar to what we write in the modulus, but it is not modulus, it is actually determinant of the matrix A. And how do you find it? Cross multiply A to D, so we get here AD, and minus cross multiply B to C, so BC. Again, when you're writing this value, this will be written with the respective signs. It means if the A value is negative, put the sign over there for that particular element and so on. So this product will be written with respect to alongside with the respective signs of each of the element. Okay, great. Next, determinant of a matrix. So if you see the matrix over here, how do you find it? Very simple, as I mentioned, A1 A2 2 minus A1 2 and A2 1. Okay, this I already explained it to you. How to solve this one? Same here, 2 into, as I mentioned, with the sign minus sign, 3 into with the sign minus 5. Cross check, minus 12. This becomes plus 15. Answer is 3. Answer is 3. Very simple approach. What about, sir, when we are actually dealing with the the major question comes from 3 cross 3 matrix and we have to deal with this only. So when you have a 3 cross 3 matrix, it means it will have an element of 9. It will have total 9 element. So to solve the determinant of this, what we do? Of course we know that. Just let me revise it once. We can use any of the rows, any of the columns or any of the 3 rows. Okay, and the value of determinant that you obtained from any of these 6 options of 3 rows and 3 columns will remain same. Means whether I use first row or third column, second row or first column, any one I use out of the given 6, my answer will not change. Okay, if I want to expand and get the determinant value across the row 1, how do you do it? Very simple. You have to take it, the pivot element will be the element of the row 1 and the cofactors will come from your other given 4 elements. So if I talk about the first element A11, I'll have to remove, so when you have got the pivot element, okay, this is your pivot element A11, remove the row and column where it is contained. See here, So this is your first row where the row 1, the first element is contained, and the first column. As I mentioned, the pivot element is A11, so write that over here, and the remaining element will become your cofactor alongside the sign of minus or plus depending upon the element's position as even or odd place. Check here, 1 plus 1, even or odd, sir? So even, it means the first position is positive. Move on to the next element. We'll have here plus minus 1 power 1 plus 2, because the element is A12. The element is A12. When you talk about A12, you're gonna remove this particular column now. You'll have this and this left. A21, A23, A31 and A33. I know you all know this, but still it's very important to not make mistakes in this. That's why just give me one more second, I'll finish it off. And check here, if it is 1 plus 2 means it'll be odd, so you'll have an alternate position as minus, and likewise you'll get the last one as positive. Let me show you. Mass 1 power 1 plus 3 element will be what? 1, 3. When you talk about 1, 3, this will be removed. The third column, you'll have these 4 left. So right here, A21, A31, A22, A32. This is the result of expansion for the given determinant or given matrix across the row 1. And if you simplify this by solving this entire result, you'll get what? You'll get the determinant value. Okay, check here. So this is minus 1 power even number, so positive. Minus 1 power odd number, so negative. Minus 1 power again 4, so even number, positive. If you want, you can remember the sign like this: plus minus plus, plus minus plus, minus plus minus, and plus minus plus. Plus minus plus. That's how you remember the sign of the positions of each of the element. Okay, moving on. Now, before I move on to the next part and solving the questions on it, understand this very clearly. Very important right now to utilize our time, because beta, this is the last time we can put efforts for KCET. Why have we launched the Masterstroke? Okay, even though your boards are here, because this is the last time you're going to study, properly for KCET. After that, you have to rush. You'll have only 20 days, 30 days left before your, KCET is there, and you will not find time to revise the concept, know the formulas for all the 4 subjects, and write the mocks also, which is a very important part of getting a good rank, a good college in KCET. Whether you are a JE student, whether you are a KCET student, whether you are a PU student, if you are writing KCET, your goal is what? What is your goal? Your goal is better speed and accuracy. Your goal is speed and accuracy, because questions are not very difficult. Okay, you got to get them right, and you got to get them right in 60 minutes. That's the goal. Okay, I know you have 70 minutes of time, but understand, no, the last 10 minutes don't count it only. Count 60 minutes, and you have to solve how many questions? 60 questions. That needs speed and accuracy together. Good thing is we don't have negative marking, but still it is a big ask. Okay, whether you are JE aspirant, whether you are whatever you think that you are, still it will require efforts, it will require practice of many mock tests. And for that we have brought from the team who has taught, who has trained, who has helped students from last 25 years, more than 25 years. They've helped students to get good rank in Karnataka, good rank in KCET. That team has designed this particular ABHYAS KCET test series, right? Not me. I did not make this test series. The team at Deeksha has brought up this test series by their years and years of experience. Okay, here it is, your ABHYAS KCET test series, which comprises of 4 free and 31 paid mock tests, which becomes total of 35, and subject cover is your PCMB. Physics, chemistry, maths, biology is a subject cover, and of course alongside that you also get access to chapter wise KCET PYQs, and you all know how important the PYQs are. So you get the PYQ as live test for free in this. Okay, that's part of this particular thing, and you get all of this in the way of exam pattern. Means you get to write the exam. Of course you all know that this is an online test. Okay, this is an online test, so you'll have a platform, you'll have timer going, you have to solve the 60 questions in the given amount of time. So you'll be a proper exam pattern, okay, and timing. If you want to practice OMR, bring a KCET OMR, print it out and keep it next to you to get a better understanding of the live mock exam. Okay, so you can use that, and this is recommended by your toppers of last year, your seniors. Prajwal was at 171, Kiran, and everybody you can see over here, and many more got a very good rank when they referred the ABHYAS. So wherever is your preparation, if you're doing well, you will do better. You are struggling, you of course gonna improve. Okay, so whatever is your preparation will certainly enhance that if you have taken the ABHYAS KCET. Okay, I'm telling you, it's going to be one of the smartest investment that you make at a price of 1499. Completely worth it, beta. Okay, so do not take it lightly when I'm telling you for that long, and many have already enrolled. Okay, there were many students in KC90. You know that KC90 was the course that we launched, a 90-day program. Those all got the access of this course for free. So those are already using this. Many new students got this course, this test series. So they are all ahead of you. Okay, so you should not delay it anymore. You will not, even if you purchase this or take this after 1 month, of course you can purchase it, but you will not find time to solve these many mock tests. Okay, so that's very important to take it right away. Yes, question on finding the determinant. Now I know your time is very important, but this also was very important. Okay, I know your time is very important. I should not waste even a minute of it, but this also is extremely important, and it is for your benefit only. Yes, okay, come on. If you have matrix A, can you find determinant? Yes, we can find the determinant. And who will give me the answer for this one? All of you. All of you will give me the answer for this one. Okay, in the comment section. This I'm not doing, right? This I'm not doing. Determinant questions are actually pretty easy, very easy. Whether it is PU2 or whether it is KCET, the questions are very easy. Give me the answer for the first question. This is your question number 1. So give me the answer for this in the comment section. Okay, important points to remember. Let's decode it one by one. Determinants obtained along any row or column is same, as I mentioned already. For easier calculations, we shall expand the determinant across that particular row or column which has maximum number of zeros. Okay, that row or column which has maximum number of zeros. Of course, right? Because if you take, let's say if I have a determinant with the first element as 0, second element as 0, last element as let's say 5 or -5, whatever it is, then for the first two element the whole result will be 0 only. You got to just expand across this particular row. Okay, so if you have let's say 2 or 5, 2, 7, 1, 8, 9, take across this, your determinant value will be -5 times of 5, 2, 7, 1. That's your result. Correct, no? That's your result. Yeah. Point number 3, while expanding, instead of multiplying by -1 power I plus j, just remember that the odd positions will have a sign of negative and the even will have a sign of positive, as I explained over here. If you remember, plus minus plus. You might think, sir, this is actually position 1, 2, 3. I'm not talking about the position of 1, 2, 3. I'm talking about the sum of the I plus j values to be a position of even and odd. Okay, 1 plus 1 is even. That's why it's an even position. So minus, plus, again plus minus, and minus plus. Clear? Determinants are not multiplied as we multiply as matrices. Of course, matrices, when you multiply, you go and multiply row to column and all of that, right? But determinants are scalar values. Means if you have determinant of A, determinant of B, let's say this value comes out as 7, this comes out as minus 7. If you take the product, answer will be what? Minus 49. Why would you multiply row to column? You don't multiply row to column. Okay, moving on. Few notes. Some properties, again, very useful in question solving, in especially KCET, and of course in PU2 also. When you have determinant of A power n, okay, you can simply take the determinant on the A and take the n power of the determinant instead of the matrix. Yes, where A equal to KB is given, I'm looking to apply what? Let's say matrix A is given as KB, and if I apply determinant on both sides, I'll write k power n determinant B. K is a constant, it's a scalar value, B is a matrix. So simply take k to the power n, where n represents the order of the matrix B. N is the order of the matrix. Okay. For any two determinants A and B, the property holds true. Determinant of the product of AB or determinant of A into determinant of B, or BA, AB transpose, A transpose B, or A transpose B transpose, all will be always same, because determinant of A is equal to determinant of A transpose. Same thing. Just because you took transpose doesn't mean that the determinant value will also change. It looks very silly, very simple, but it is very important property. Okay, and this right here is same as this property, the same one. Okay, means here we wrote A as KB, here we have taken just KA. Okay, when K is given, answer will be K power n times A of determinant, n will be the order of the matrix A. Find the value of X for which the determinant A vanishes. Now think about it. Of course, which row or column we're going to use? So we'll use the third column or third row because it has maximum number of zeros. Okay. Sign, do we know that, sir? It is going to be, sir, plus, minus and plus only. So I'll use plus X. When you do that, you're going to remove these two, the row and column, and what you'll have? X plus 4, X plus 1 minus and minus 1 times of 2. As I mentioned, never forget to write the elements with its respective sign. Okay. Now vanishes means determinant will be coming as 0. I'm looking to find the X value. When they say determinant of A vanishes, it means determinant of A becomes equal to 0. Let's solve this now. Yeah, X plus 1, X plus 4, and like this we have, what do we get? X square plus 4x and x, so 5x. Okay, and we have over here as plus 4, no, plus 2. Okay, right? So far so good. Yeah, x plus 1, x plus 4 makes sense. Okay, sorry, I forgot to write that. X is multiplied to both these, no, not just this element. So you'll get here 2x over this, my bad. So you'll get here x cube plus 5x square, and we have over here 6x, right? 6x, no? I forgot to write this x product of this also, but it'll be like that, okay? Oh yeah, the x cube 5x plus, what is that? Yeah, 5x square plus 4x plus 2x becomes 6x. Take x common again. You get here what? X square 5x plus 6. Yeah, x square 3x plus 2x. So product are what? X plus 3 and x plus 0. Sorry, 2. X plus 3 and x plus 2 equal to 0. The values of x are basically either 0, minus 2 or minus 3. 0, minus 2 and minus 3. Check the factors that you have. X, x plus 3 and x plus 2. So from here you get 0, minus 3 and minus 2. Okay, cool. Moving on. Next, find the value of x. It's a determinant, so we can't compare it. We'll just find the value. We get over here 2x square minus 40, 18 and plus 14, I guess. 32 plus 40, 2x square. That's 72, x square is 36, x value is plus minus 6. Option A is correct. Next, area of triangle. In coordinate geometry we know that we have learned this formula in coordinate geometry, area of triangle. Okay, and how do we find this value? By using the determinant. It's very simple. You write the coordinates like this, x1, y1 for the 3 points that you have. Check here. This is a point A, point B, point C. If A is x1, y1, B is x2, y2, and C is x3, y3. Okay, then you write the coordinates in what? In the 2 row columns, x1, y1, x2, y2 and x3, y3. The last one to be 1, 1, 1 because it is 2D shape. Okay, there's no 3 dimension over here. And simply find the determinant value of this. What are you gonna get? Check here. x1 times of y2 minus y3. Over here, y1 minus y3. Over here, y1 minus y2. Check here. x1, y2 minus y3. Move this inside, you'll get what? Plus x2, and it'll become y3 minus y1, and right here x3. Now if you multiply this whole thing by 1 by 2, if I take here 1 by 2 here, this also has 1 by 2 as whole, and this also has 1 by 2 as whole, of course, and here also 1 by 2 as whole. This is the same result. Have you look? Check. So you can use the determinant application also in the area of triangle. Yeah, clear? Moving on. Condition of collinearity of 3 points. What's the meaning of collinear points? It means that all these points A, B, C, B is here, A is here, and C is here, lie on the same line. Lie on the same line. Okay. Then why we are using this concept of triangle over here, sir? I'll show you. So if I draw a triangle like this, A, B, C. Now I'll try to what? Move this point A close to the line BC. What will happen if you do that? Check this out. You'll have a position like this after some time if you keep moving it. Of course the area is reducing. Yeah, it doesn't matter. But yeah, getting my point? Yes. Move it further down. So this is your first phase. Now I'm going to the second phase. Check here. Very close now it has become. So it is point B, A and C. Further move it towards this. You're gonna get something like this. The line BC and the point A over here. Okay, just above. Okay, and if you continue like this, you'll end up with the line BC and the point A on it. So there comes that a position where the triangle actually has no area or the zero area. So whenever they talk about collinear point, we take them as a triangle with zero area. This is the area of triangle. Put it equal to 0. So basically this determinant value of the coordinates, if it is 0, means the points x1, y1, x2, y2 and x3, y3 are collinear in nature. Very simply explained. No points, no difficulty over here. Yes, let us continue. Okay, find the values of k if area of triangle is 4 square units and the vertices are k0, 4, 0, 0, 2. Area of triangle 1 by 2. Vertices are k0, 1, 4, 0, 1 and 0, 2, 1. Am I right? k0, 4, 0 and 0, 2. This is given as 4. Now when you talk about area, you have to take both plus and minus sign, because I'll ask you a question. Can the, just answer, I don't know, you can't answer me right now, but you can answer in your mind. Start the question. Can you get a determinant value as negative? Answer is yes. Can the area be negative? No. So if you solve a determinant and the area comes out as negative value, will you say the area is coming as minus 4? Of course not. It means sometime when the determinant value comes out as negative, we still take it as positive entity because we are talking about the area now. Okay, the physical quantity is area now. In that regard, so when you are going back from the area to what? To your mathematics, the calculation part, okay, you have to introduce both the signs because we don't know exactly whether the result was positive or negative. Yes. Now bring this 2 on this side. You get here this determinant value equals to plus minus 8. Determinant you can find across this particular column because 2 elements are 0 and the sign, if you remember, minus plus minus. The sign is minus plus minus. Okay, so you get here minus 2 times of, remove this particular row and column, you get k minus 4 and you get this as plus minus 8. Okay, solve it then. I get here minus 2k plus 8 equals to plus minus 8. Now I have two results. I'll use two conditions. Minus 2k plus 8 equals to plus 8. So 8 it cancels. I get k value as 0. And the other one will be what? Minus 2k plus 8 equals to minus 8. On this side you get minus 2k equals to minus 8 minus 8. So minus 2k is minus 16 and that gives me k value as 8. So k is either 0 or k is 8. Either 0 or 8. Clear? Have a look. Superb. Next, minors and cofactors. Minors are what? So when basically, remember I was deleting the ith row and column, means I was getting a pivot, right? If I have this element, let's say 1 4 3 6 2 13 5 1 0. if I talk about one element, create a pivot, okay? So if you create a pivot of, let's say, element number 1, the remaining matrix after cancellation of the or removal of the contained elements row and column, yeah? So the pivot element was over here as 1, if you remember, this was 1. Now you remove this particular element's address. Address is what? The first row and the first column. The remaining matrix is called as your minor. So this one basically, so if you remember, your A11 is 1 and your M11 means the minor of the first element will be 2, 13, 1 and 0. That's my minor. So same way, for how many elements are there over here? The total of 9 elements. Total of 9 elements. So for each element you'll have what? 1 minor. So you get total of 9 minors. Total of 9 minors. And the symbol to write minor is M11. Clear? Okay, sir. Now, determinant of, yeah, same thing. Determinant of the order 3 cross 3, we get 9 minors corresponding to the 9 elements. Minor of an element aij of the determinant of order n will be n minus 1 order. Of course, we know that this determinant is what order, beta? This is 3 cross 3 and this is what? 2 cross 2. So this is 1 less than the order of original determinant. Determinant is of the order n. This is 1 less than that original determinant of order. Yeah. Cofactors, very simple. So we just found a minor, no? We just found a minor and we know the symbols of each of the positions. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So based upon the element you're talking about, for example, if I talk about the first element, which is A11, then you go and write the M11. That is going to be what? If you remember, M11 will be your A22 and A23, and you'll have here A32 and A33 because you've removed the first row and first column. This is your M11. Okay, if you are not sure, I'll show you. Somewhere I wrote, no? This element I will read, right? This is A22, A23, A32, A33. Same thing I've written over here. Okay, that's my M11. What about A11? A11 represents, or sometimes we write this as Cij also, or C11, because we're talking about cofactors. So cofactor has two symbols, either C11 or A11, C1 or A11. And how we write that? So combine this with the sign minus 1 power I plus j M11, means just attach the sign of that element with the minor. Check here. We're talking about first element. First element is even position, right? 1 plus 1 is the even position. So write the plus sign only. So plus M11. Plus M11. So depending upon the element we're talking about, for example, I want to talk about this element. What is this element called as? A31. M31. What about C31? It will be simply plus M31. What about if I go C32? It will become minus M32. Because 3 plus 2 is odd, and hence you have a minus sign over here. Okay, so the element's position is minus. It means the minor will be of the opposite sign to your cofactor. Clear? Yes, this is understanding of cofactor, minor and the elements. Expansion of determinant in terms of cofactors. So if you use the same rows element and the corresponding cofactors, A11, A12, A13, and of course you know how to write the other 6 elements, and the cofactors also will be like this only: A11, capital A12 and A13, and of course you'll have the other 6 cofactors. So if you multiply corresponding elements to the cofactors, so small a11, capital A11, small a12, capital A12, small a13 and capital A13. When you multiply these, what is it called as? Elements to the corresponding cofactors from the same row or column, then you end up with what is it called as? This determinant. This is called as determinant symbol. Okay, so Determinant is nothing but the product, the sum of the products of the element and its corresponding factor of any row or column. I can take first row, second row, third row, doesn't matter. I can take any row or column, but the condition is the sum of products of corresponding element and its cofactors. If you don't do that, let's say here first element and the cofactor of 2, 1, that is the second row's first element. If you go like this, it will be always 0. So if you don't use what, same row or column and the corresponding product of element and the cofactor, if you use anything other than this combination, you end up with what, 0. I have written the definitions for all of you. Download the PDF from the WhatsApp community and get the access to all the PDF and notes. Find the minor and cofactor of all the elements in the determinant. So for the element A, what is my minor and cofactor? Check here. Position I'll write first. Plus minus plus minus. Sorry. Minus plus, no? Because A11, A12, A21, A22. So plus minus and minus plus. What is the minor of first element? You're going to remove this. You have D. Cofactor also will be D. How come, sir? Because there the position is positive. Next, C. C's cofactor and minor will be B. Minor is B. And cofactor will be a negative position. So minus B. What about the element B? The minor will be what? For B, you'll have C. And what about this? It's a minus sign. So minus C. The last one is the element is D. The minor will be for D, A, and the position is what? Positive. So simply A, right? My bad. This is how you write the minor and cofactor. Sign is given over here. Easy, very easy thing, not a difficult thing at all. Adjoint of square matrix. Now you can feel that we are moving to the world of inverse very soon. Okay, so adjoint means that when you arrange all these cofactors, what is cofactor? The capital A11 signs. Okay, so when you arrange all these cofactors, this is your elements, this is your elements, and this is your cofactors. When you arrange this and then take the transpose or dashed T, okay, check here, this remains as it is. A11, A22, A33 comes as it is. This is not changed, but this A21 comes over there and A12 comes over there, means this is come over here and this is come over here. Basically I've taken the transpose, or symmetric transformation I've taken over here, of course. So A21 comes here, A31 comes here, A13 goes there, and likewise when you do that, this particular value is called as adjoint of A. So adjoint of A is nothing but cofactors matrix taken transpose. I'll repeat, adjoint of A is nothing but cofactors matrix taken transpose. Next, adjoint of matrix A in this is given as this. So there's a rule for this kind of matrix. Okay, there's a trick for matrix of different adjoint. For 2 cross 2 matrix, the trick is you interchange these two, okay, across this one. You have to apply condition of interchange, okay, and across these two you have to do what? Sign change. Check here, sign change. So in the adjoint, D goes up, A comes down, and C becomes negative and B becomes negative. So across the diagonal element you interchange, and across other element you sign change, but only for 2 cross 2 matrix. For a 3 cross 3 matrix, things changes. I'll show you, don't worry. If I have here 1 5 0 2 1 3 0 0 1, this is a matrix. I hope it is invertible. Let me check, but it doesn't matter, we have to find the adjoint, right? So what you do in this case, write the same matrix over here. I'm looking to find, this is a matrix A. My goal is to find what? My goal is to find adjoint of matrix A. Of course we know how to find it, right? Now we can find the cofactor of each of the element. First find the minors, apply the signs to get the cofactor and apply that, but that'll take time. Okay, how to do it in exam and faster and get the right result? 1 5 0 2 1 3 0 0 1. So repeat the first 2 rows. So 1 5 0, repeat the first 2 rows I repeated the first two rows. This over here, sorry, I can do better. This over here and this over here. Now repeat the first two columns. So you get 1 2 0 1 2, and here I get 5 1 0 5 1. Now you got, after repeating the first two row and first two column in that order, first you repeat the row, then you repeat the column, what are you gonna get? You'll get a 5 cross 5 matrix. Check here, 1 2 3 4 5 columns and 5 rows also, 1 2 3 4 5. Okay, so you get 5 cross 5 matrix. Now in this given matrix that you got, remove the first row and first column. Remove the first row and first column. Now simply start taking cross multiplication in the vertical arrangement like this, and write the result in the matrix adjoint A in the horizontal rows. 1 into 1 is 1, minus 0 into 3 is 0. So first element is 1. Same way, 0 into 0 is 0 and 1 into 5 is 5. Difference will be minus 5. Second element is minus 5. You get here 5 into 3 is 15. 1 into 0 is 0. It means simply 15. That is my third element. This is how you get my first row of adjoint. You don't have to take transpose over here. This is not cofactor. This is the adjoint directly. Okay. Don't make this mistake, sir. I get this matrix and then take transpose. No. This is already taken care of. Okay. Next. 3 into 0 is 0. 1 into 2 is 2. Difference will be there. So minus 2. I'm talking about these now. Okay, next, 1 into 1 is 1, 0 into 0 is 0. It means my element is 1. 0 into 2 is 0, 1 into 3 is 3, with a difference means minus 3. My second row is also complete. The last one we'll see. Yeah, the last one we'll see now. The last one is this one. 2 into 0, 1 into 0, both are 0 means this is 0. Next, 0 into 5 and 0 into 1, again 0 means again 0. We have 1 into 1 is 1 and 5 into 2 is 10 means minus 9. And this is your adjoint of A. Very simple way to find it out. Yes. So I have taught you this. Watch it again and again if you have any discussions, any problems regarding this, because I will not teach you this again when I'm solving the questions. I have taught you the method of finding adjoint. You have to do the calculation from here onwards. Next, moving on. Singular and non-singular matrices. Now as I am telling you that I am moving towards, the class is moving towards your inverse of matrix. Okay, means how do you find inverse of any given matrix? So for that, first thing that we need to know was finding adjoint, and next thing is to know what, whether inverse exists or not. And for that, what is there? You have something called a singular. Means when you have the determinant of the given matrix as 0, then matrix A is called as singular matrix, and you say that inverse does not exist. Okay, when it is non-zero, then you say it is non-singular. Then you say it is non-singular, and then you say inverse exists. Inverse exists. As simple as that. Okay, check here. 4 into 4 is 16. Minus 16 is going to be 0. Here you have 5 minus 6 will be what? Minus 1. Hence it is non-singular in nature. Got it? Moving on. As simple as that. Nothing different over here. Some important theorems. Okay, this we will use to solve and get the relation for our inverse also. So please pay attention to this. This is the same property we will use to get our relation for inverse, the formula for inverse. Okay, theorem number 1 is what? A adjoint A equals to adjoint A into A equals to determinant of A i.e. Okay, n is what? Order of the same matrix A. Theorem number 2, if you have A and B are non-singular matrices of the same order, then A, B and B are also non-singular matrix of the same order. What it means is, if determinant of A is not 0, determinant of B is not 0, then what will happen? A, B and B A will also have non-zero value of determinant. Yeah. Next, theorem number 3, a determinant of the product of matrices is equal to the product of their respective determinant. This we already discussed, I remember. Yeah. Let A be the non-singular matrix of order n. Then adjoint of A power, determinant of adjoint A is given as determinant of A power n minus 1. What if we have two adjoints? What if we have two adjoint? Then answer becomes determinant of A power n minus 1 the whole square. Depending upon the number of adjoint, you will take the power of that. Okay, and so on. Margin of an element of determinant order n. Yeah, So if the determinant order is n, then minor order will be n minus 1. That was the definition. If you remember, I wrote that. I explained that to you very clearly. Which of the following options is correct in a given determinant? Okay, order of minor is more than order of determinant. That's false. It's less actually. Minor of an element is always equal to cofactor. Not always. Not always. Minor cofactors are not always equal. They are sometimes equal when talking about the positive position of the element. Cofactor of the element aij is obtained by multiplying the minor by this. This is correct. Yeah. So you get cofactors as minus 1 power I plus j times mij. That's correct, no? The minor by this. So option C is the right choice. Option D is what? Value of determinant is obtained by only multiplying element of row or column with corresponding cofactors. Not only multiplying. Multiplying and adding also, no? Only multiplying is not good. You have to multiply and add. Remember? The result is this. A11, A11, A12, A12, A13, A13. This is the determinant value, not just multiplying. Yes, so option C is the right choice. Adjoint of A. Transpose of cofactors, correct. Thus B. Yeah. Determinant of adjoint of A will be what? We learned it right now. It will be what? Determinant of A power n minus 1. Right, no, we have only one time adjoint. N value is 3, means determinant of A power 2. Determinant of A is what? Check here. A square minus 0. Value is A cube. Answer will be what? A cube the square. So A power 6. Sorry, small a power 6. I mean. Yeah. C. Got it? A simple question. Yes. Properties of adjoint and inverse of a square matrix. Have a look. If you're taking transpose and inverse, it remains as inverse of the transpose. No changes. You can transport it like that. And adjoint of AB will be simply adjoint of B times of adjoint of A. You take the product. You have to take the B part first. Okay. A is an invertible matrix. Then adjoint of A dash will be simply adjoint of A dash. Okay. Adjoint A dash is simply adjoint of A dash. And then we have this property. Adjoint of A. This is not determinant outside. Okay, just see the difference, guys. Here we don't have determinant outside. This is simply adjoint of A is given by determinant of A power n minus 2 into A. Difference is there. Directly MCQs can be asked over here. The properties of determinant can be directly asked in the MCQs. So be careful. Remember, revise them again and again. Okay. Property 5, I explained this already. If you have 2 adjoint, power comes 2. If you have n adjoints, power becomes 3 or whatever it is. N means n. If you have 3 adjoints, means 3 power, n means n power. Okay, to the n minus 1. This is a very common property. Determinant of A inverse is simply 1 by determinant of A. Reciprocal law, as simple as that. Okay, what is this? Property number 7, if the product of two non-zero square matrices is a zero matrix, then both of them must be a singular matrix. Yes. Means what? If determinant, so matrix is not zero. I'm not saying the singularity. I'm just saying matrix is not zero. Product of two non-zero square matrices means they are not zero matrix, not a null matrix. Difference is there. Okay. I'm not saying this. If the product is coming as yes, if the product of two non-zero matrix is 0, means when AB is coming as 0, okay, it means that determinant of A will be 0 and determinant of B will be 0. They are not a zero matrix, but product is 0. It means determinant of A and determinant of B will be 0 because they are both going to be a singular matrix. Adjoint of K is given as K power n minus 1 adjoint of A. Some properties, remember this please. Inverse of matrix now. So for this what we do, remember I told you guys when I was teaching you matrices product that product of matrix is not commutative in nature. Generally product of matrix is not commutative in nature, means AB and B are not always equal. It is equal if they are invertible to each other, means they are inverse of each other. Okay, that's the result. AB BA equals to IN, the same order. And how we get the result of this? like it. So you're going to use this first theorem. I taught you right now. Nothing is new. Check here. Theorem number 1. Where's the theorem number 1, sir? Here. A adjoint equal to adjoint A times A and determinant of A times In. Same theorem we have written over here. Check. And divide everything by determinant. Divide this by determinant, so like this. Divide this by determinant, so also like this. And this will be determinant by determinant, so cancel, only I is left. So this is nothing but your matrix B. This is nothing but your matrix B. Check here. AB, BA is I. AB means the value of B is coming as adjoint of A by determinant of A. And I mentioned B is inverse of A. I can write this B as then A inverse, and what is the formula for B? Adjoint of A by determinant of A. And as you can see clearly over here, determinant of A comes in denominator, then of course determinant of A is a scalar value, cannot be equal to 0. That's it. That is it. Please check. Excuse me. Yes. Properties of inverse of matrix. If you're taking inverse to inverse, the original matrix appears. AB inverse is what? B inverse into A inverse, means you apply the inverse on the product. The product will use the reversal law, of course. And K inverse will be what? 1 by K for the reciprocal law, reciprocal rule that of exponent, and A inverse will be as it is. And A into A inverse is same as A inverse A, as simply your identity matrix. How come, sir? Remember, this is that AB and BA is I. That's the same thing, right? AB, BA is I. Only square matrices have adjoint and inverse, as mentioned already, and AB and C are invertible matrices. Then of course the reversal law will hold true also. ABC inverse will be what? C inverse, B inverse, A inverse for the product of ABC taken inverse at the same time. Working rule to find the inverse of matrix by using formula. First thing is basically to find the determinant of A and check it is 0 or not. 0 means inverse does not exist. 0 means inverse does not exist. When it is non-zero means when it is non-singular, then inverse will exist. And how do you find that? You find the adjoint first and divide by determinant. How do you find an adjoint? I told you the right way to do it means find the cofactors, finding the minor first, then cofactors, putting it in the matrix, and then you do what? Take transpose and get the result, or simply use the trick I told you to find the 2 cross 2 and 3 cross 3 matrix adjoint. For 2 cross 2, what did I teach you? Take the mirror image, take the interchange of the diagonal element. Another element is just sign change. And for the 3 cross 3 matrix, I showed you a way. Remember, I showed you a way over here. There was this, sir. There was this. Yeah. This was the way to find a 3 cross 3 matrix adjoint. Yes. Clear? We were here. Okay. So you can do that. Adjoint of A is found. Divided by determinant of A, you get the inverse of the matrix A. The matrices of this B adjoint A is given. C is 3A. Find the adjoint of B determinant by C. The saying adjoint of B. Adjoint of B will be what? Adjoint of B is what? Adjoint of A. So adjoint of A determinant by C. C will be what? 3A determinant. What I've done is simply use the substitution of the given information. B is adjoint of A. I wrote B as adjoint of A, and C is 3 of A. Okay, apply. Adjoint of A becomes what? Determinant of A power. Determinant of A power n minus 1 remains as it is, and number of adjoint will be the power of n minus A. 3A will become what? 3 power n and determinant of A. Check here. So determinant of A we have to find basically as find that determinant of A. We get here 1. So 9 plus, what is it? 9 plus 4 minus 1. Check this out. 3 minus 4, which is minus 1, right? No, if I do this minus 1, I get 3 minus 4 plus 2, you get minus 1 and minus 3, so minus 5, correct? No, minus 1 and minus 3 is minus 4, sorry, not minus 5, minus 4, minus 1 and minus 4, sorry, minus 3 will be minus 4. 9 plus 4 is 13, so 13 into 1 is just this, plus 1 and minus 8, am I right? Plus 1 and minus 8, 14 minus 8 is 6. Determinant of A is coming as 6. Okay, N value is 3, so I get this value as 6 power 3 power 2, and we get here 3 power 3, and we get here 6. Okay, Check here, I'm getting here 6 power 6, and we have 3 power 3 into 2 into 3. What is 6 going to be? 6 is 2 into 3. Check numerator now. 6 can be written as 2 power 1 second guys. 6 is written as 2 into 3 power 6 by, what do we have? 3 power 4 into 2. Continue now. 2 power 6 into 3 power 6 by 3 power 4 into 2. Cancel this. 3 power 4 cancel this one with 3 power 2, and 2 cancels this one with 5. 2 power 5 is 32, and we have into 9. Something is wrong. Yeah, something is wrong. N minus 1 means, okay, sorry, n minus 1, my bad guys, horribly wrong. This will be n minus 1, so 2, no, this will be not 6. Sorry, my bad. So this will be what? This value will be changed. Let me just do that. It will become 2 power 2. So 6 power 4 I will have. 6 power 4 I will have. This will be 4 actually. Okay. So I have to change this result. My bad. Calculation mistake. It can happen. Forgive me 1 second. Just last 1 minute. Pakka. Done. Check here. So we have 2 power 4 and 3 power 4. So I'll end up with what? 2 power 4 into 3 power 4 by 3 power 4 into 2. 3 power 4, 3 power 4 cancelled. 2 power 4 is going to be 16 by 2 is 16 by 2 is 8 actually. So let me know the answer is right or not. Answer is coming as option C. I'm not sure. I don't remember the answers that well actually. So let me know whether the answer is correct or not. Okay. For this question, if I call this question to be, I don't know the count now. So but last 1, and that's it. 2. So third from the last. Okay, third from the last. Third from last. What is the answer for this one? Please let me know in the comment section. Okay, C should be right. This is clear. Clear. Okay. Clear. Okay. Find B if 2 cross 2 matrix B is that. Okay, we can find that. How do you find B, bacha? To find B, of course, you need to find the inverse over there, right? I'm looking for determinant. Okay, no. We're looking for determinant, not B. So let's do one thing. Apply the determinant now. So determinant, if I call this to a matrix, let's say A and B, this is C. Apply determinant over here. You get determinant of A times determinant of B times determinant of equal to determinant of C. This will be what? Check here. This will be your 14 plus 15. That's right. And over here we'll have simply B, and over this determinant of B, I mean 17 into 13. Okay, I get this as minus 17 into 13 and plus 47. Okay, good. We have excuse me, let me do the multiplication. Yeah, 1 carries 5. 17 and plus 5 will become 22 and plus 47. Okay, and I want to find the value of determinant of B. This will be what? 29. Check here. Minus 2 to 1 plus 47 will be what? 7 is going to be what? 4. And we have here 1 against 7. 174 by 29. Okay. Yes. 9 6 will work. Check here. 9 6 is 54, carries 5 in then 12 plus 5 is 17. That's correct. So my determinant V is coming as minus 6. Is it right? Option D is correct. Option D is correct. Check here guys. Simple calculation, not difficult at all. Yeah, done. Next, consistent and inconsistent systems. So to get whether it is of which cases involved, we have linear equations involved over here. A system of equation is said to be consistent if solution is what? 1 or more, means basically infinite, and inconsistent when there is no solution, means when it is going to be non-singular or those cases. Yeah, we'll see that. Here it is. If you have 3 equations, a1 x, b1y and c1 z and so on, 2 more in the same variable x, y, z, and t1, d2, d3 are the constant on the other side. Okay, you can form this condition. Constant, the coefficient matrix, variable matrix and the constant matrix. This is your coefficient matrix, this is your variable matrix, and this is your constant matrix. When you do that, you're looking to find what? The value of x. So how do you find value of x? Simply by taking A inverse product with B. So basically adjoint of A product with determinant of A times B. This is going to be the result. We have equations like this. A 5-marker question comes in your boards based upon the same concept. Yeah. Now, to understand the nature of solutions, we have this approach. What is this? Case 1, if A is a non-singular matrix, then we'll have two cases, whether it is going to be singular, unique, or more than one, means the infinite number of solutions cases. We'll see. As inverse of matrix is unique, so the system of equation is consistent. So this matrix equation gives us unique solution for the given system of equations. The method of solving system of equations is known as the matrix method. Okay, this is something that already we wrote it on this side. You can see x is A inverse B. X is A inverse B. Same thing is that. Now case 2, when determinant is 0, we have two cases. Adjoint of A times B is non-zero, means the given system will have the no equations, so inconsistent. So no solutions means inconsistent. And when adjoint of B times 0 is 0, then it can have either infinite many solutions, or it can have no solutions also. Okay, but usually we refer to this one as infinite solution only. Okay, this question, sec tan 0, 0, 1, what is this going to be? Let's check. Determinant of A, I can find across this particular row, plus minus plus only. So plus 1 times of sec square theta minus tan square theta. We know this value. Plus 1 into 1. Tan square plus 1 is what? Sec square. So it's going to be 1 only. Determinant of A is coming as 1. It is not equal to 0. Means inverse exists. That's the right choice. Okay. I think the session is over now. Yes, this is the end of your class in Masterstroke for the chapter Determinant. It was a simple concept, not very difficult. So do practice the questions on it. How can you do that? Of course, you have PYQs to solve. You have so many questions, so many books to that you can refer. But alongside all of that, I'm gonna come back with the class of live, where I'll solve the most relevant questions from the chapters Matrices and Determinant in one live. Okay, very soon you'll get that. So do join that particular class to solve the questions with me in the live session. Okay, so that's all for this particular class. You can join me right now in this journey by simply subscribing to our channel, and also being a part of our WhatsApp community. The link for that will be given in the description of this particular video. Go check it out and join right away. You'll get the note of this session over there only. Okay, that's it in this class. I'll see you in the next one. Till then, take care. Bye bye.